So it's a review for chapter 15. And this is just one of 2 days of review that we're going to do. So I want to start off today with one of these. Let's say that I had sine of 2 theta. Without even looking at the sheet, you should be able to say, oh, that's no big deal. I can replace that with 2 sine theta cosine theta. All right, that's one I want you to memorize, but you are going to have that sheet available on this test. All right, so why do I bring that up right now? Because if sine of 2 theta is equal to 2 sine cosine, then when I show you this one, sine of 2, and instead of theta, I put something that would give you a theta, which is the inverse tangent of 1 over x, then it's going to work out the same way. Okay, so first off, I hope I've trained you well enough to know that whenever you do this, you start on the inside, and then you figure that out. Now, this is an inverse tangent, and so that means it's going to get an angle. And I like to write these this way. Tangent of some angle will be 1 over x, just because you're more used to seeing it that way from that circle trig chapter. Then I have told you that whenever we're in a situation where we have a variable, then you're going to be in the first quadrant. And so in the first quadrant here, you're going to put a triangle which has sides opposite and tangent is opposite over adjacent, so 1 over x. And then you're going to get the last side, which is going to be square root of x squared plus 1 squared, which is still x squared plus 1. All right. Now, why did I draw all of that? Okay. Because that helps me figure out the angle in question. So now I'm going to rewrite this out because I know that sine of 2 theta is really 2 sine cosine. I'm going to write that underneath here. 2 sine of the angle, cosine of the angle. But wait, you might say, what's the angle? We don't need to know the angle. We just need to know the cosine of the angle and the sine of the angle. Okay, so now that I got the triangle drawn with all of the sides labeled, remember me saying how that was important? Then we can do sine of that angle, which is opposite over hypotenuse. So 2 times that part is 1 over square root of x squared plus 1. And then multiply by cosine of theta. And what is cosine? It's adjacent over hypotenuse. So x over the square root of x squared plus 1. Now, something neato happens because when you multiply square roots, let's say I had square root of 3 and I times it by the square root of 3. Do you get how that's the square root of 9? So it's 3. When you multiply square roots that have the same thing underneath, the answer is the thing that's underneath. So now I'm going to multiply that 2, which is like a 2 over 1, across the top, and I'll have 2x. And on the bottom, those square roots, which are equal to each other, so therefore when I square root them, I'll get x squared plus 1. Look at that. All right, so that's how you do that one. And it all came down to sine of 2 theta, which is on the sheet if you didn't know it. But the most important part was drawing that triangle for the inverse tan. And then you can just, once you've got that triangle drawn with all of its sides, you can just plug things in. All right, let's do another example. And I encourage you, as always, to stop me, try to do these. This is a review day. Like, you're supposed to be able to do this stuff by yourself. All right? So let's say I wanted to do cosine of alpha plus beta. You feel like that might be on the sheet? Of course it's on the sheet. All right, so I'm going to pause for a second while I remind myself what it is. So I realized after I looked at the sheet that yours is in terms of x and y, and so I decided I would rewrite this as cosine of x plus y. And just a reminder that right off the sheet, that is cosine of x, and then cosine of y. And then if you're adding in here, then you subtract over here and take a wild guess what we have left. Do you think it's all cosines? Of course not. Then it's sine of x, sine of y. Okay, so now, knowing that, when you see the next problem that I'm going to give you here, hopefully you'll see that, oh, this is one of those. So, cosine, here's the problem you would be asked to solve. Cosine of the inverse tangent of x, which is really like x over 1, right? And then I'm going to say plus, so it follows that same pattern, so I don't have to look up a different one. Inverse sine of x over 2. Now, if I just had to start with this problem, I would be so lost unless I was able to grab that identity sheet and find out that, oh, I just need to find cosine of the angle and sine of the angle. So I have two different angles, x and y. This is going to tell me one of my angles. This is going to tell me my other angle. All right, so let's take a minute and draw this. And remember, when it's variables, I'm just going to go right to quadrant 1. TOA, opposite, over adjacent. This must be square root of x squared plus 1 because it's the longest side, so you'd add them. All right, and then this one, I'll make a different one. Make it in green this time. Sine is opposite over hypotenuse, x over 2. And this side would be square root of, well, it's got an x squared and it's got a 2 squared. Which one's bigger? The hypotenuse has to be bigger, so that 2 squared has to be bigger, minus x squared. So that's really the square root of 4 minus x squared. That's that third side right there. Okay. Now, remember that we really don't need to know what that angle is. We just need to know cosine of that angle and cosine of the other angle. All right. So now we're going to start following this pattern. And I don't see any reason I should write it over again, so I'll just use this one up here. And I'm going to now try to find cosine of x. X is going to be our first angle, which is this guy over here. Okay. So cosine for that one, cosine of this angle right here, cosine is ca adjacent over hypotenuse. So 1 over square root of x squared plus 1. And next one I have to do is cosine of y. So now I'm going to go to the other angle, over here, the green one. And in here, cosine is adjacent over hypotenuse. And so it's square root of 4 minus x squared over hypotenuse 2 minus, now again, sine of the first angle, back over to here. Okay, so sine in that triangle, sine is opposite of hypotenuse, x, oh, hold on, touch something, x over hypotenuse, square root of x squared plus 1. And last but not least, sine of y, the y being this other angle over here now. So sine is opposite over hypotenuse, so x over 2. And now, through an amazing quirk of fate, we end up with the common denominator. In fact, on this kind of question, we always will. So if I put this all together, I now have a common denominator of 2 times the square root of x squared plus 1. And on the top, I'm going to have square root of 4 minus x squared. And don't you dare think you can take the square root of that and give me 2 minus x. Totally not true. It's complicated why, but we have a long enough video as it is, so I'm not going to try to explain that. But don't try to take the square root of that. Minus x squared. There's my answer. Okay, it's pretty intense stuff. What does it boil down to? A couple things. You have to be able to do inverse. Like if you didn't know how to do this part right here, I'm going to circle it in blue, let's say. This part right here, you have to know how to find inverse trig, but it's in the middle of a identity. So you really have to be able to do both. All right, one last thing I want to cover for you because in class you're going to have something like this to practice. Let's go with cosine of 4 theta is equal to root 3 over 2. On this kind of a question, I like to do what's called a U substitution. I like to say, act like this part right here was just theta, or in this case, I'm going to say just U. I'm going to say let 4 theta be U. And then I'm going to say cosine of U is equal to root 3 over 2. The point here is I'm going to act like that 4 theta is just a normal variable, and I'm going to solve it like normal. And how many answers would you have for this if this was like normal? Well, I would have 2 answers in the 2 spots where cosine is positive. So here's one place that cosine is positive, and then all students take calc. You see the other place that it would be positive down here. All right, so I'm going to ask you to pause the video for a second, and I'd like you to figure out the original question was cosine of 4 theta equals root 3 over 2. Pause the video for a second. See if you can do this. Watching me, you're going to remember 10% of it. You need to try it. So pause the video and resume in a second after you've given it a try. Okay, some of you probably didn't pause. Boo. I hope you paused and you tried it yourself. Starting with up here, cosine is adjacent over hypotenuse, so we have square root of 3 over hypotenuse is 2, and this must be a 1. And so then what's the angle across from? It's across from a 1, which means it must be a pi over 6. So my first angle here is pi over 6. Then, was this an inverse trig question? No, it wasn't. Why did I even ask that question? Because if this was inverse trig, I'd need to use a negative angle as I went down and got this answer. But it's not inverse trig. This was just a solving trig question. So I'm now going to go around and say it's a whole bunch of pi over 6s. The other answer is, let me think, 6, that'd be 11 pi over 6. So I have 2 answers, pi over 6 and 11 pi over 6. But that's what U was equal to. As in, you aren't done with the question yet, because remember we said U was going to just stand in for the 4 theta. So now this is actually 4 theta right there. 4 theta and 4 theta. And now I have to fix it, I have to, oh wait, but I never said that there was a limit on this. So that means we have to now add 2 pi k. So 4 theta is equal to pi over 6 plus 2 pi k. And 4 theta is equal to 11 pi over 6 plus 2 pi k. And then to actually solve it, the last step, I promise, is you're going to go through and multiply everything by 1/4. 1/4, we'll cancel off that 4. 1/4, 1/4, 1/4 here, we'll cancel off that 4. 1/4, 1/4, and now it's just about cleaning up our answers. So our final answer here is theta would be pi over 6 times 4 is 24, plus that is 2 pi over 4, which would be canceling to pi over 2 times k, and theta equals 11 pi over 24 plus pi over 2 times k. So I didn't have any restrictions, so that means I got to leave this with the plus 2 pi k's in them. But what if, just what if, the problem had said you have to give answers between 0 and 2 pi? Like your theta has to be between 0, can be equal to 0, and 2 pi can't be equal to 2 pi. Then I would have only given 2 answers so far, and do you remember that if you have a 4 in here, then you're going to actually have 4 times as many answers? So normally I have 2 answers. This would have 8 answers. All right, so the answers that I already have are pi over 24 and 11 pi over 24. And to find more answers, I would just go and put in, and I'm not going to finish this one just because that's a lot more answers I'd have to find. But I'm just going to show you how to do one more answer. If I put in a k equals 0 would just make the pi over 2 disappear, and I'd have pi over 24. But if I put in a 1 for k, that'll give me this one more of my total of 8 answers. So that would be pi over 24 plus pi over 2. And since I'd rather have that be in 24s, that's pi over 24 plus 12 pi over 24 would be 13 pi over 24. That's one of my 8 answers. Pi over 24 is one of my 8 answers. 11 pi over 24 is one of my 8 answers. And then when I put in a k equals 1, and I end up with 1/2 pi again, but I really want to make that into 12 pi over 24 so I can add it to this. I'll get one last one here, and then I'll stop. This is going to be 23 pi over 24. Now you might be asking, how many times would I have to put in k? Would I have to put in 2 for k? Yes, you would. Would I have to put in 3 for k? Yes, you would. When would you stop putting in 1, 2, and 3? Would you go forever? No, because you would go until you had 8 answers. So far, I've got 1, 2, 3, 4 answers out of the 8 I would eventually end up with. All right, that's all I have for you for today. I know that was pretty intense, but this is about the toughest stuff. This is only about R3 type tough material. So head back to take a little Schoology quiz, and then I will see you in our Q&A session.